I bought a portable air conditioner for my parents, and this is a hose coupler that allows me to connect two hoses. I need to have a similar part to connect the hose to my air vent. One of the sides will be the same, but on the other one I don't need to have the ribs on the outside, so I can plug the whole thing into the wall socket. And today I will show you how to make that in FreeCAD. First, choose Part Design from the drop-down menu, then create a new document, a new body and a new sketch. Select the XZ plane. Zoom out the document, then click on the Polyline tool. Now roughly draw the profile of the tube without the ribs. Constrain the first and the last points on the horizontal line and make sure all the lines you draw are either horizontal or vertical. This will save you some time fixing them later. Now we have one redundant constraint. Right-click to deselect the Polyline tool, then click on the redundant constraint and press the Delete key on your keyboard. Then you can close the Report View window. Select the bottom and the top lines and press the Equality button to make them equal. Then select either one of them and set its length to 2.5 mm. This will be the thickness of the tube. Now let's set the vertical measurements. The first one is 40 mm. This is the side that will go into the wall socket. The biggest strip that goes around the tube should be 6 mm. The side where the hose should be connected should be 30 mm. I'm taking the measurements from the original part which I showed you at the beginning of the video. The rib should be sticking out 5 mm. We have 1 degree of freedom, so the only thing left to set is the radius of the tube. Select the lower right corner of the sketch and the center point, then click on the horizontal length button. To find the radius, we have to divide the diameter by 2, then subtract the thickness which we set earlier. As you can see, we can put the calculation directly in the dialog box and the program will do the math for us. In my case, the radius of the tube should be 65 mm. The sketch is fully constrained, so we can close it. Now click on the Revolution button. The tube is almost ready. We only have to make the ribs that will be the thread for the hose. Click on OK to confirm the revolution function. Now select the front view from the cube in the right corner. Click on the Create a New Sketch button. Now select the XZ plane. Click on the View Section button to reveal the horizontal and vertical axes. Click on the Rectangle tool and draw 2 rectangles as shown in the video. Right-click to deselect the Rectangle tool. Select the left sides of both rectangles and make them equal. Then set the length of one of them to 2.5 mm. Select 2 of the horizontal lines and make them equal. Then set the length of one of them to 5 mm. Select 2 corner points and constrain them vertically. Now set the vertical distance between both rectangles to 11.5 mm. We have 2 degrees of freedom, so we have to set the horizontal and vertical position of the rectangles. Select the lower right corner point and the center point, then set the vertical distance to 6 mm. Then select the same points again and set the horizontal distance. To calculate the horizontal distance, you have to divide the diameter by 2. In my case, the horizontal distance should be 67.5 mm. The sketch is fully constrained, so we can close it. Now it should look like this. To make the ribs, click on the revolution button again. Now we have ribs going all around the tube. We don't want this. To fix it, I will change the angle to 70 and click on OK. Now, as you can see, the ribs are shorter. But we need to have the same ribs on the opposite side of the tube. To do that, I will click on the Polar Pattern button. Select the second revolution and click on OK. To position the ribs correctly, select Vertical Sketch Axis from the drop-down menu. Please don't forget to support me by liking the video and leaving me a comment below. Now you can click on OK. The last thing that we can do to replicate the original shape is to add a fillet to the edges. Zoom in, hold the Ctrl key on your keyboard and click to select all of the edges of the ribs. Now you can select the fillet or the chamfer option from the buttons above. I will use the fillet option. In my case, 4 mm looks good, so I will click on the OK button. And this is how I made the part I needed. I only need to print and install it. If you need to have ribs on the inside like the original part, you only have to draw them in another sketch and revolve them later. To save it, click on the Model tab, then select the body, go to the File menu and select Export. This way you will be able to save it as an .stl file. As always, you can find this part uploaded on my Thingiverse profile. Since the air from the air conditioner will be hot, I will use PETG filament to print the part. PETG can start to deform under load at temperatures around 80 to 85 degrees Celsius, so I hope it will be enough. Just a friendly reminder, if the hose of your portable air conditioner is too long, buy insulating sleeves. They are very effective in preventing the heat from the long hose from getting back into the room. While making the video, I messed up some dimensions and the part I made wasn't fitting the wall socket. The principle of designing the part is the same, and you can still download the files from my Thingiverse profile and adjust them to your needs. The file with the part designed in the video will be named Demonstrational Part, and the usable part will be named Custom AC Exhaust Hose Adapter. This is what the second version of the hose connector looks like. So now I will show you the corrections I made. As you can see, the inner radius at the bottom is set to 65 mm. And to fit into the wall socket I have, the outer radius is set to 65 mm as well. The thickness varies between 2 and 2.5 mm, which I think is enough for the part to be stable. I also corrected the rip on the first sketch. It was 6 mm and I set it to 9 mm. In the original part it is exactly 9 mm. The only correction on the second sketch is the width of the ribs, which I changed to 2 mm as on the original part. The last correction I made was choosing to use chamfer instead of fillet. This doesn't make much difference to the functionality, but I think it looks more like the original part. Here you can see a side-by-side comparison between the old and the corrected part I designed. The corrections are subtle, but they make a big difference. This is a wall socket similar to the one I have on my wall. And now you can see how the new part fits inside it. It's the perfect fit and exactly what I needed. In my next video I will show you exactly how I connected the holes, so if you're interested you can check it out. That's all for today, have a nice day and see you next time.